Now, let's look at the third and final axis of rotation and put a small deviation in it to help explain why it is unstable, unlike the other two. So, as before, let's just focus on a half of the object. Now, as you can see, even just by eyeballing it, there's a lot more mass on this side than there is on this side. Now, as you probably remember from before, the axis of rotation naturally goes through the center of mass of each of the halves of the rotating object, as well as the overall center of mass in the middle. So, just like with the wooden stick, the axis of rotation will shift toward the more massive side of the object until there is an equal amount of mass on either side of the axis of rotation. Now, the axis of rotation goes through the center of mass of each of the halves of the object, as well as the overall center of mass in the middle. This is exactly what happened with the previous axis of rotation we discussed in part 2. But, as before, we also have to consider the torque created by the unevenly distributed mass of the original spin. So, because this object is spinning clockwise relative to us, the downward momentum of this side, which is more massive, will overwhelm the upward momentum of this side, which is less massive. So, this half of the object will gain an overall momentum downward. The opposite thing will happen to the other half, which will gain an overall momentum upward. This effect will create a torque that can be represented by an axis of rotation like this. As before, this torque can be divided into two parts. One part going along this axis of rotation, and another part going along this axis of rotation. The original spin, which was going along this axis, but then shifted to this axis, will cancel out the part of the torque going this way, leaving a spin going this way and a certain amount of torque going this way. But where is the axis of rotation? To figure this out, we need to rotate this object like this and like this at the same time, and then locate the points on this object that are still relative to the center of mass. So, if I rotate this object like this and like this at the same time, then these 2 points are still relative to the center of mass, because their momentum this way cancels out with their momentum this way. So, like before, the axis of rotation is like this, which is just what we started with. But, when the other side comes around, at these 2 points, the momentum this way cancels out with the momentum this way, making these 2 points still relative to the center of mass. So now, the axis of rotation is here. So, the axis of rotation started off here, and then because of the effect we just discussed, it flipped over to here. Then the same effect will take place again, so the axis of rotation will just keep flipping back and forth. But how will the object actually move when the axis of rotation flips back and forth like this? Well, the object will just be spinning normally until the axis of rotation becomes unstable. Then the object will briefly spin in a new direction until the axis of rotation assumes its new position, at which point the object will continue spinning normally. You can see this flipping behavior in a video of me spinning this object along its unstable axis in slow motion. Now, that 20+ minute explanation is probably hard for you to remember, so I'm going to quickly review everything that I've talked about. A rectangular object has 3 main axes of rotation. One that goes through the shortest dimension of the object, so it spins like this. Another that goes through the intermediate length dimension of the object, so it spins like this. And a third that goes through the longest dimension of the object, so it spins like this. This axis of rotation and this axis of rotation are both stable, meaning that irregularities in the spin stay small and don't grow. The axis of rotation that goes through the shortest dimension of the object is stable because the centrifugal force pulls the matter in the object away from the axis of rotation. If the spin has an irregularity in it, then the matter in the object is closer to the axis of rotation than if the spin axis was lined up with the shortest dimension of the object. Therefore, because the centrifugal force pulls the matter in the object away from the axis of rotation, it will naturally tend to line up the object more perfectly with the axis of rotation. You can see this effect in action in a slow motion clip of me spinning this coaster. This effect is the reason why this rotational axis is stable. Now, the next rotational axis, which goes through the longest dimension of the object, is also stable. This is because if the axis of rotation has a small irregularity in it, and you just look at 1/2 of the object, then you'll see that the mass is unevenly distributed on either side of the axis. This creates a torque that continuously changes as the object spins. This changing torque makes the axis of rotation wobble. However, when it wobbles, its difference from being perfectly lined up with the longest dimension of the object never grows from the original discrepancy. This means that any irregularities in the spin will stay small, making this axis of rotation stable. Now, the third axis of rotation, which goes along the intermediate length dimension of the object, is unstable. This instability is also due to the torque caused by the unevenly distributed mass on each half of the object when there is an irregularity in the spin. Now, instead of keeping the irregularity under control, as it did in the previous axis of rotation, this torque causes the axis to violently flip back and forth. This is why this axis of rotation is unstable. This concludes the summary. I also have a video linked in the description of somebody spinning a T-shaped object along its unstable axis on the International Space Station. If you've made it this far, I applaud your patience. I hope this video series has taught you something. If you enjoyed this video, be sure to subscribe to my channel. Tell me in the comments what you want my next video to be about. Thanks for watching.